It's funny. When you think about it, you have these AI systems that can do these incredibly complicated calculations. Like
Yeah.
they can just generate these amazingly realistic images,
Yeah.
and yet you can give them something that literally any child would understand, like basic common sense,
Uh-huh.
and they're totally baffled.
Yeah.
It's like that human ability to just like get it,
Yeah.
without having to have everything laid out step by step.
Yeah.
That seems to be like the real frontier in AI right now.
It really is. It's fascinating because you see AI mastering these very specific domains.
Yeah,
But that real flexible, adaptable intelligence that we humans have, that's still really a challenge.
totally.
And that's really what we're looking at today in this material.
Yeah, exactly. And today we are going deep, deep
Yeah.
into a really interesting set of stuff.
Yeah.
We've got a blog post that gives us a kind of hands-on look at building some pretty neat generative AI workflows. And then on the other side, we have a set of research papers that are really pushing the boundaries of what AI can do.
Yeah, this is a really cool combination.
Yeah,
Because you get to see the practical applications of these tools and then the really forward-thinking ideas
totally.
about where AI might be going.
Yeah.
Helping cars drive themselves, new perspectives on art,
Uh-huh.
and even like how we should be measuring how far AI has come.
Totally. So your mission, should you choose to accept it,
Please do.
is to glean the most interesting and the most relevant insights from this material.
Right.
We want to paint a clear picture of what's happening in AI right now, what are the breakthroughs, and how do we understand all of this in a way that's fun and engaging and doesn't feel like an AI lecture.
Yeah, we don't want to overwhelm people.
No, no, no.
Still it down.
Yeah.
What are the big leaps and why do they matter?
Okay, so let's start by digging into this blog post.
Right.
It was written by somebody who actually went out there and built an app that demonstrates some real-world generative AI use cases. And they use some pretty cool tools, Streamlit for the user interface, Grok for speed.
I was going to ask about that.
Yeah, you can think of that as a high-performance engine for AI.
Okay.
Pydantic to make sure all the data is structured correctly.
Got it.
And then LangGraph, which is kind of the framework that ties all the AI pieces together.
Interesting.
And you can actually go try this app out yourself. It's on Hugging Face Spaces at hf.cowspaces deep pry 24 LangGraph workflows.
Oh, very cool.
Yeah, so you can actually see how this stuff works in action.
So what's really neat here is that we get to see how these different technologies are all being used together in one project.
Right.
And LangGraph particularly is meant to help build these more sophisticated AI systems
Yeah.
that involve multiple AI agents working together.
Right.
So it's not just one AI doing one thing.
It's like a team,
It's a team, exactly.
which is kind of going back to what we were talking about at the very beginning.
Absolutely moving beyond those single-purpose AIs.
Yeah, and the blog post focuses on 3 specific problems that they tackled. First, they wanted to create customized learning path generator.
Okay.
And they use something they call an orchestrator synthesizer workflow to do that.
Interesting.
Then they did a peer code review system, and they use a parallelized workflow for that.
Uh-huh.
And then finally, they had a tool for blog generation.
Right.
And for that one, they used an evaluator optimizer workflow.
So these are great examples of how to structure these AI agents
Yeah.
to solve different kinds of problems. And even the names of the workflows
Yeah.
give you a clue as to how the AIs are interacting.
Totally. And the way the blog post is laid out is actually really smart. They start with a quick primer on what agentic AI is versus just a single AI agent.
Okay.
Then they explain why they decided to use the LangGraph framework for the project.
Uh-huh.
And then they actually walk you through this really neat 6-step process that they followed.
Okay.
And then they wrap it all up with a summary.
That explanation of agentic AI is really important
Yeah,
for understanding this approach to generative AI.
absolutely. So the way they explain it is agentic AI is a part of generative AI.
Right.
But instead of just focusing on creating new content like text or images,
Yeah.
it's all about solving complex problems by using multiple AI agents or even just different AI tools.
Like a team.
It's a team.
Yeah.
It's less like you have one superhero AI.
Right.
It's more like a team of specialized agents that are working together,
Yeah.
and each one of them has their own expertise.
That's a great way to put it.
right.
Because then you get this much more complex and nuanced outcome
Yeah.
than if you just had one AI trying to do it all.
Right. And when they talk about their process, they break it down into 6 stages.
Is
So
that-
you start with a brainstorm and requirement phase.
Uh-huh.
Then you move into the dev phase where they're actually writing code.
Right.
Then you go to the debug phase
Yeah.
to,
Iron out the kinks.
iron out the kinks, exactly.
Yeah.
Then
Yeah.
you have the UI phase where they're building the user interface. Then the CI/CD phase where they're making sure that the code is updated and integrated and deployed correctly.
Right.
And then the final phase, the deploy phase, where it actually goes live.
This breakdown is great.
Yeah.
Because it shows how much engineering goes into these AI ideas.
Right.
It's not just about the algorithms.
Yes.
It's about building the whole system around them.
Exactly. And it's in that brainstorm and requirement phase where they really showcase that orchestrator synthesizer workflow.
Okay.
And the example they use is this customized learning plan generator.
Mm-hmm.
So the basic idea is you have these different AI workers, and each one is responsible for summarizing a different topic.
Got it.
And then you have this central synthesizer agent that takes all of those summaries and figures out how to put them together into a well-structured roadmap.
So it's customized for each user.
Exactly. It's tailored to the user's needs.
And this is really different from just doing things in parallel. Because in parallel processing, you're just breaking up a task into these subtasks that all happen at the same time.
Right.
But with the orchestrator synthesizer, it's dynamic.
Yeah.
So the orchestrator decides what the subtasks should be.
Based on the user's request.
Based on the input, exactly.
Yeah.
So it's much more flexible.
Yeah. It's actually thinking about what needs to be done.
It's not just dividing it up into fixed pieces.
Right.
It's making decisions.
Yeah. And then you move into the dev phase where all the code gets written.
Right.
And then the debug phase. And in this phase, they specifically talk about using Langsmith,
Okay.
which is a really cool tool that basically lets you look inside these complex AI workflows.
So you can see what's going on.
Yeah, you can see what's going on. And they use it to make sure that all the individual work files, so all the different AI agents, are actually working correctly.
That kind of visibility is crucial.
Yeah.
Because these land graph systems are so complex.
Yeah.
You really need to be able to track what's happening
Totally.
and spot any errors.
And then you move into the UI phase,
Right.
where they use Streamlit to bring all these different AI use cases together into a single user-friendly interface.
Makes it easy to use.
Yeah, so anybody can go in and interact with these powerful AI workflows.
Very cool.
Then you have the CI/CD phase, which is all about making sure that when they make updates or changes to the code,
Right.
it's all integrated and deployed seamlessly.
Smoothly.
Exactly.
Yeah.
And then finally, you have the deploy phase where they actually launch the app and they do it for free on platforms like Streamlit Cloud and Hugging Face Spaces,
Amazing.
which means you can actually go and play with it yourself.
So it's a full circle.
Yeah, it's a full circle from the initial idea to the final product.
Yeah.
And I think that really underscores the idea that this stuff is being used in the real world.
It's not just theoretical.
Yeah, people are building and deploying these intelligent systems.
Absolutely.
Okay, so we've seen some really cool practical applications of generative AI.
Yeah.
We've seen how these multi-agent systems are being built.
Right.
Now let's jump into this collection of research papers, because this is where it gets really interesting.
Okay. I'm excited.
This is cutting edge,
Yeah.
really cutting edge stuff.
The forefront of AI research.
Absolutely.
And we picked out a few that show advancements in totally different areas,
Yeah.
each one giving us a glimpse into what's possible.
Okay, the first one on our list is a paper titled Seeing the Future, Perceiving the Future, a unified driving world model for future generation and perception.
Okay, that sounds like science
I
fiction.
know, right?
Like a movie?
Yeah.
Seeing the future?
Well, this paper introduces something called Unifuture,
Okay.
and it's on RE Cold if you want to look it up. And what they're trying to do is tackle 2 really important tasks for autonomous driving at the same time.
Oh, wow. 2 at once.
Yeah.
Okay.
So the first is they're trying to predict what the future driving scene is going to look like.
Predicting the future.
Predicting the future, and then at the same time, they're trying to perceive what that future scene will actually be.
Okay, so not just what it looks like,
Right.
but also the layout.
Yeah, like the depth information.
Like where things are.
Yeah, so it's not just seeing the cars and the people around the vehicle right now.
Right.
It's trying to figure out where they're going to be in a few seconds.
That's incredible.
And then understanding that environment in a 3D sense.
So it can make good decisions.
Exactly, so it can navigate safely.
That's amazing.
Yeah.
So how are they doing this?
Well, they developed something called a dual latent sharing scheme.
Okay, what's that?
It's basically a way for the visual information and the depth information to learn from each other
Oh, wow.
within a shared representation.
So they're working together.
Yeah, they're working together, and then they also have this other thing called a multi-scale latent interaction mechanism.
Sounds complicated.
It is, but what it does is it refines the predictions
Okay.
at different levels of detail. So you get a more consistent and accurate prediction.
So it's not just like a blurry vision of the future.
No, it's a very detailed,
It's a clear picture.
yeah, very clear picture.
Very impressive.
Yeah, and their model actually did really well.
Really.
It outperformed other models that were designed to just do one of those tasks.
So it was better at both predicting and perceiving.
Yeah, which is pretty amazing. And they actually made their project publicly available on GitHub.
Oh, cool.
So if anybody wants to really dive into the technical details,
That was always a good sign.
yeah, it means that they're sharing their research with the world.
It shows they're committed to open science.
Exactly. So you can check that out at github.com/dk-leeing unifuture.
I'll definitely be taking a look.
Okay, let's move on to something completely different.
All right, what else have we got?
So the next paper is called Context-Aware Multimodal AI Reveals Hidden Pathways in 5 Centuries of Art Evolution.
Okay, so we're talking about art history now.
Yeah, art history through the lens of AI.
That's fascinating.
I know, right?
I love this kind of interdisciplinary research.
Me too. So they use this really powerful AI model called Stable Diffusion.
Okay, I heard of that one.
Yeah, it's a generative AI model.
Uh-huh.
And they used it to analyze 500 years of Western paintings.
Wow, that's a lot of data.
It's a massive data set.
So what kind of information were they looking for?
So they were looking at 2 main types of information.
Oh, okay.
First, they were looking at the formal elements of the paintings.
So like the colors, the brushstroke.
Exactly, the visual stuff.
Got it.
And then they were also looking at the contextual elements.
Okay, so what the paintings were about?
Yeah, the themes, the subject matter.
Interesting.
So what did they find?
Yeah, what did the AI uncover?
Well, one of their key findings was actually really surprising.
Okay, I'm intrigued.
They found that the contextual information, so what the paintings were actually about,
Yeah.
was way better at distinguishing between different artistic periods and styles, and even individual artists.
Than just looking at the visual style.
Just looking at the visual stuff.
Wow, that's counterintuitive.
I know, right? You would think that the visual style would be the most important thing.
Yeah, you would think that like Renaissance art looks different from Baroque art,
Right.
and that's how you would tell them apart.
But what they found is that the subject matter, the themes, the ideas,
Yeah.
are actually more important.
That's amazing.
Yeah, it really challenges some of the traditional approaches in art history.
Yeah, because art historians tend to focus on the formal analysis.
Yeah, but the AI's findings suggest that societal changes and cultural shifts have a huge influence on art.
Which makes sense when you think about it.
Yeah, because the world around the artist is going to shape their work.
Of course.
And they even did this really cool experiment where they fed potential future contexts.
Like hypothetical future events.
Yeah, hypothetical future events into the AI and had it predict how art might evolve.
Wow, so they were simulating the future of art history.
Yeah, it's pretty wild.
That's incredible.
Okay, let's shift gears again to something a little more practical.
Okay, bring it back down to earth.
Back down to earth. Yeah, the next paper is titled, "It is Too Many Options: Pitfalls of Multiple Choice Questions in Generative AI and Medical Education."
All right, so this is about how we evaluate AI.
Yeah, and specifically in medicine.
That's an important area.
It is, because we're seeing AI being used more and more in healthcare.
Yeah.
So these researchers created a new benchmark called FreeMedQA.
FreeMedQA.
Yeah.
Yeah.
And what's interesting is it gives medical questions to the AI in 2 different formats.
Okay.
One is the traditional multiple choice,
Right.
and the other is free response, where the AI has to come up with the answer on its own.
Interesting.
Yeah, so they tested a bunch of different large language models on this benchmark,
Uh-huh.
and they found that there was a massive drop in performance when the models had to do the free response,
Right.
compared to just picking from multiple choice options.
So they looked really good on the multiple choice.
Yeah, they seemed really smart.
But when they had to come up with the answer themselves,
They struggled?
they...
Yeah, and the drop was way bigger than what you'd see with human test takers.
Wow.
Yeah, so this suggests that maybe multiple choice tests aren't the best way to measure AI's understanding of medicine.
Because they might just be recognizing the right answer.
Right. It might not be true understanding.
Yeah, not actual knowledge.
Yeah, and they did another study, a masking study, where they started covering up parts of the multiple choice questions.
Okay.
And they found that even when most of the question was hidden,
Yeah.
The AI could still do better than chance on the multiple choice,
Wow.
but their free response was still terrible.
So it's really gaming the system?
Yeah, it's gaming the system. It's not really understanding.
So we need better ways to evaluate AI in medicine.
Absolutely, especially as it becomes more integrated into healthcare.
Totally.
We need to make sure it actually knows what it's doing.
Yeah, we can't just rely on multiple choice tests.
Okay, let's touch on a couple more papers just to show you how diverse this research is.
Okay, I'm ready.
So we have one called AI-Powered Prediction of Nanoparticle Pharmacokinetics, a multi-view learning approach.
Okay, that's a mouthful.
It is, but it's basically about how we can use AI to understand how tiny nanoparticles behave in the body.
Oh, wow.
Yeah. And this is important for drug delivery.
Right, because nanoparticles can deliver drugs.
Exactly.
So they're trying to predict how these nanoparticles move through the body.
Yeah, where they go, how they're eliminated, all that stuff.
That's really complex.
It is, and they built this sophisticated multi-view deep learning framework that takes into account all sorts of properties of the nanoparticles, like their size and their surface charge.
Wow, so they're really looking at the details.
Yeah, and they're not just building a black box that spits out predictions. They're
Right.
trying to understand why the AI is making those predictions.
So they can learn more about the biology.
Exactly, which could lead to new insights and better treatments.
That's amazing.
Okay, another one. The pruner. Unlocking accurate 50% structural pruning for LLMs via global sparsity distribution optimization.
Wow, that's a long title.
It is, but it's basically about making large language models more efficient.
Okay.
So pruning is a technique where you remove parts of the neural network
To make it smaller.
to make it smaller and faster.
right.
And structural pruning means you're removing entire blocks or connections.
Got it.
The challenge is to do this without making the model less accurate.
Right. You don't want to lose performance.
Exactly, and that's where the pruner comes in.
Okay, so what's so special about it?
They managed to remove 50% of the parameters in this huge language model called Llama 3.170B.
That's a lot.
It's a lot.
So it's half the size.
Yeah, half the size, and they still maintained 97% of the original model's performance.
Wow. So it's almost as good.
Almost as good, but way more efficient.
That's incredible. How do they do that?
Well, they use this really clever global sparsity distribution optimization framework, which basically means they look at the whole network and figure out which parts are the least important.
So they're being really strategic about what they remove.
Exactly. They're not just pruning blindly.
Makes sense.
Okay, last one, and this one is really important.
Yeah, hit me.
Towards harmless multimodal assistance with blind preference optimization.
Okay, safety.
Safety. This is about making sure that AI assistants that can understand both images and text, multimodal,
Yeah.
are safe to use.
This is crucial.
It is, because these models are becoming more and more powerful.
And we're going to be interacting with them more and more.
Exactly. So these researchers created a data set called MMSafePO.
NMSafe-PO.
Yeah.
Okay.
And it has all these examples of responses to multimodal instructions ranked by how harmless they are.
So they're teaching the AI what's safe.
Exactly. And they also found some really interesting behaviors in these models,
Like what?
like things called modality co-defense and modality cheating.
Modality too. That sounds sneaky.
It's basically where the model tries to get around the safety rules.
Oh, wow.
Yeah. So based on their findings, they came up with a new training approach called blind preference optimization, or BPO.
BPO, got it.
And it actually significantly improved the safety of these multimodal models.
That's good to hear.
It is, you can actually see some examples and results on their project page, luyang666.github.io mmsafetoweb.
So they're sharing their findings.
Yeah, which is awesome.
Yeah.
So taking a step back from all of this,
Yeah.
it really feels like we're seeing a ton of progress in AI
Absolutely.
on so many different fronts.
There's this clear push towards making AI more human-like,
Yeah,
more sophisticated.
but we're still working on that common sense thing.
Yeah, that's still a challenge.
But we're getting there.
We're getting
And
there.
we're also seeing these really practical applications of Gen AI workflows.
Right, people are actually using these tools to solve problems.
And then there's all this amazing research happening.
Yeah, like we just saw with these papers.
Yeah, from self-driving cars to art history to medicine to nanoparticles to making AI models more efficient and, of course, the safety stuff.
It's all happening so fast.
It really is. It's an exciting time to be following this field.
Absolutely.
It's changing so rapidly.
So much potential.
So much potential, but we also have to be careful.
Right. We need to make sure we're developing it responsibly.
Yeah, and that's what makes this deep dive so interesting.
Totally.
It shows you the potential and the challenges.
And the need for ongoing research.
Exactly.
To make sure AI is beneficial for everyone.
So as you're listening to all of this, think about this.
Yeah.
With AI getting better and better at understanding and even creating things,
Yeah.
how is that going to change our own understanding of human intelligence and creativity?
That's a great question.
Yeah, it's something to think about.
It is, and if you're interested in any of these topics,
Yeah.
definitely check out the links we mentioned.
Yeah, there's so much cool stuff out there.
It's an amazing field.
So this has just been a snapshot,
A glimpse.
a glimpse into the world of AI.
Yeah.
And it's a journey that's never going to end.
It's only going to get more exciting.
So thanks for joining us on this deep dive.
It's been a pleasure.
It's been fun.
Always great to chat about AI.
Absolutely.